Pick up the nearest thing to you, and then drop it. But why does it fall? Well, gravity, of course. But what is gravity? Well, in 1915, as part of his general theory of relativity, Albert Einstein said that it is curved space-time. But what is curved space-time? Or for that matter, what's space-time? On a flat piece of paper, you can graph space-time with one dimension of space and one dimension of time. Only one space dimension, up and down, is needed to graph the path of an object falling straight down. Now, if an object is at rest and has no forces acting on it, it will follow a straight line through time. It will only get older and it won't move at all through space. Now, look what happens if I fold space-time into a cone. Now, an object following the natural straight line path through time will accelerate downwards. At first, it's moving a little bit through space during a set amount of time, but later down here it's moving a lot through space for a set amount of time. This is exactly what gravity does to objects on Earth. Now the property of gravity, that all masses accelerate toward the Earth at the same rate, makes sense, because it doesn't matter how massive an object is, it will always follow this path through space-time in the exact same way. An interesting thing about gravity is that anything with mass, the Earth, this ball, this plastic egg, or even you and me, all curve space-time and produce a gravitational field. Now, of course, the smaller an object is, the smaller and weaker its gravitational pull, so the gravity of small objects is negligible in everyday life. But the effect is real. If two baseballs were put a meter apart in completely empty space, no air and no other objects, they would very slowly accelerate toward each other, reaching a top speed of about 8 centimeters an hour, and then they would touch each other in less than 3 days. The reason why we don't see objects attracting toward each other in everyday life is because friction with the air and other things stops them from moving. For example, if we took two baseballs and put them a meter apart on the floor and then left them alone for 3 days, I wouldn't come back to find them stuck together, because the forces with which they're being attracted are so minute that friction with the ground and air would completely stop them from moving. Still, it's interesting that there's an attraction between them at all. Now you've seen the complex interaction between matter and space-time, and learned that gravity isn't just a simple tug, but a curvature in the fabric of space and time itself. John Wheeler, the physicist who coined the terms wormhole and black hole, put it like this: matter tells space-time how to curve, and curved space-time tells matter how to move. Tell me in the comments what you want my next video to be about, and subscribe for more educational content. Thanks for watching.